Hello, 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 and welcome everyone to this IBM CodeSF event, which is part 2 in a series of blockchain-themed events that'll be held in July and August of this year. The next event in this series is happening next Tuesday and every Tuesday after that until August 7th. For those of you who are new to IBM CodeSF, we're a team of developer advocates here in the Bay Area, and we host in-person and online meetups, lunch and learns, workshops, and other exciting events. So you can meet cool subject matter experts and learn about open source cutting edge open source technologies. I cannot speak this morning. So just a few community guidelines before we get started. Let's keep the chat relevant to today's topic. And if you have any questions, please pose them in the Ask a Question section here at the bottom of the screen. And upvote any questions that you'd like to have answered by Lennart at the end of the session. So he'll be going back at the end of the session, looking at the questions that have been upvoted, and he will answer them then. So today we have Lennart Frantzell, an IBM CodeSF developer advocate, who will be presenting on building an end-to-end blockchain application with Hyperledger Composer. Take it away, Lennart.
Thank you, Maya. And hello, everyone. So we're going to talk now today about creating blockchain applications with Hyperledger Composer. This then follows last week's talk where we introduced blockchain and Hyperledger itself. And now the question is then, we have a ledger, which let me start with something else before. Let me start with a word from our sponsors. Call for Code, if you haven't heard it, is a very interesting initiative for building global solutions for disaster preparedness. And it is sponsored by IBM, the Linux Foundation, UN Human Rights Council, and the American Red Cross. I participate in this thing. I was down in SVL, the IBM Silicon Valley Lab, 2 weeks ago, and participated in this event, and it was really great. We learned a lot, and I urge you to do the same. Just go to callforcode.org and sign up there. It's all free, and you'll learn a lot of interesting things. Having said that, back to Hyperledger Fabric. So last week we described Hyperledger Fabric, a shared, replicated, permissioned ledger, and how that is changing the world, especially for business networks. The question now is then, how do we, how do we program the Hyperledger Fabric? It isn't really obvious how to do that, and that's what we're going to talk about this week. Let's start with some building blocks that will help us understand how to do the programming. We know we have the blockchain, Satoshi Nakamoto's digital ledger. We talked about that at length last week. We have the Hyperledger, which is an umbrella term, an open source collaborative blockchain effort run by the Linux Foundation. And then we have the Hyperledger Fabric, which we introduced last week. It is a blockchain framework hosted by the Linux Foundation. And now we are going to introduce two new concepts. The Hyperledger Composer, which is a development tool for building blockchain business networks, and chain code, which is like stored procedures written in Go or Node.js or in a while in Java, and it will handle the business logic. So Hyperledger Fabric, Hyperledger Composer, and chain code are the three concepts we're going to talk about today. We're going to use Hyperledger Composer to create chain code that we will launch on Hyperledger Fabric. And this is the way it looks: Hyperledger Composer, chain code, and Hyperledger Fabric. Let's now talk a little bit about Hyperledger Fabric, which we need to know before we get started. The Fabric has three components. Membership services, which manages digital certificates and access, because this is a permissioned environment where you have to get permission to join. Peers, which are like nodes, and which hold the ledger. We remember the ledger from last week. A peer is also where the chain code is running. So the chain code we will create now here will run on the peers. And then we have ordering service, which keeps the peers in alignment. So membership services, peers, ordering service, and chain code. And for more information, we have a link at the very bottom where you can read more about this. Here we have a graphical view of things. Membership services We have an application SDK that you get when you join. We have the peer running, and we have the chain code running on the peer, and then the order over on the right. These are all the components necessary to create chain code. Hyperledger Composer, that is a development tool that makes it very easy for anybody who is not a programmer to create applications for Hyperledger Fabric. And we're going to go through that now in great detail. The important thing about Hyperledger Composer is that it is all free, it is up on the web, and if you want to, you can go and click on the link here on top and bring it up yourself right now. You don't need anything except a laptop to use it. And you can create a complete application just using the Hyperledger Composer. So here we have it, Composer, playground.mybluemix.net. And then we can click on Let's Blockchain. And here is what we see when we do that. On the left pane, we see Hello Composer, and we can click on that to get started with a basic sample network. On the right, we can click on Deploy a new business network. So let's do that. Here we see that there are a number of templates. One basic sample network, an animal tracking network, a pond network, car auction network, etc. We have 12 sample networks. You can select any one of these, and it is fully functional from day one. So this is important. You don't have to start from scratch, but you can start with an already created network. Now we're going to go deeper down here and look at this sample network. On the right-hand side, we have the README file, basic sample business network. And now we see, what does it consist of? It consists of one participant called sample participant, one asset called sample asset, one transaction called sample transaction, and one event called sample event. These are the only components necessary for creating a business network. Sample assets are owned by the sample participant, that makes sense. And the value property on a sample asset can be modified by submitting a sample transaction. So we use transactions to modify assets that are owned by participants. The sample transaction emits a sample event that notifies applications of the old and new values. Only 4 components: participant, asset, transaction, and event. Over on the left-hand side here, on the pane there, you see the about README file, the model file, CTO file, the script file, and an access control file. So let's take a look at those 4 files. Here we have the model file. This is the entire model file, and this is a model of the network we are going to create. It has a namespace. It has an asset that we call sample asset, identified by an asset ID. And you can see that the asset ID is has a string value underneath on line 21. We see on line 22 a pointer to sample participant, and that is an owner. And then we see a string value for the sample asset. We see a sample participant below that. He's the owner of the sample asset. It is identified by a participant ID. You see this, we see the participant ID underneath here on line 27, and the first name and the last name. And then on line 32, we see transaction, the name sample transaction, and the sample asset named asset, and the string new value. This is a new value we will give this value. And sample event finally, sample asset, string old value, and string new value. This is the model file. You notice here that there are no functions really here. This is just a listing of all the participants, transactions, events, and assets. Quite simple for even a non-programmer to start to code this thing. Then we come to the script file. This script file is written in JavaScript and defines what you can do with the values here we have. Here we have a sample transaction. It has an old value of the asset, and then we get a new value of the asset. We change the old value to the new value, and that's all we're really doing in this script file. It is a little bit more difficult to write a script file and then simply list the values that we saw on the previous page, but still this is not really very terribly difficult to do once you figure out how the system works. So the model file, the script file, and then the access control list. This lists which members have access to what parts of the model. And here we start out by giving everybody access to everything. Later, when we have come further into this thing, we can make the access more fine-grained and not give everybody access to everything. And here we have more access control code. And again, we will give everybody access to everything to start with. But later, when we want to, we can throttle the access as we feel like. So here then we have the basic sample business network. We remember we have a participant, an asset, a transaction, and an event. The question now is, how do we begin to program this thing? So the nice thing here is that all the code we need is contained in the web page. So here we see the sample participant. We have a class, we have the ID, we have the first name and the last name. And we simply swipe this thing, copy and paste it into the editor, and we're off and running. Then we have a sample asset, a class, asset ID, owner, and value. The same thing. And then a transaction that will set the new value and erase the old value. This is step by step, are the steps we have to take to create our application and make it running. Here we see now we have the new participant that we have created. His name is Toby, and he likes blockchain. You can see the class, org example, base example participant, participant ID, and the first name and the last name. And we can add any other attributes for any of the participants we want to later. The asset ID number, owner, and value. And you see in here we have the original value because the asset has one value to start with, and we will then change the value and update it. And here we see the transaction. We use the transaction to set a new value. And this is not, again, very complicated things. And here we have the event, a little bit more complex. But you see we are setting a new value, and the new value is entered here. Transaction ID and timestamp. And the transactions are always kept on the blockchain and never changed or erased for that matter. Now we have written our first application, and the question is, what do we do now? Well, what we do now is we will deploy the BNA file, and I'll explain what that is in a second, to the Hyperledger Fabric and the cloud. BNA means Business Network Archive, and it's also called banana file. And here we have the pieces we have to play with. We have assets in the model file, the CTO file, participants and transactions. We have transaction functions in the script file. We have access control rules in the ACA file. And we have something we have not talked about, a query file that we can use when we run this application. All of those components are put together into a BNA file, a Business Network Archive file. And then we can deploy that in the Hyperledger Fabric in the cloud or locally. Or we can deploy it in the web browser if we just want to play around with this thing and test it out. So these are the components of the language. They all fit together, and we deploy them, and we can begin to run. But there's more to this environment than meets the eye. We can see here that we have data modeling. We have shown that. We have the JavaScript. We have shown that. And we have the web playground. We have shown that. We also have NPM client libraries. We have an editor. And then we have something interesting. We have CLI utilities, because the Composer is also a runtime environment. And this is very, very important, because when we deploy our application, we then can have a REST API that we can use to connect to this thing from outside the world we have been in here, and connect to outside systems, and therefore add GUIs to it, because of course the data modeling does not have any graphical user interface, but we can add that via the CLI utilities. And we also have code generation, and we have the loopback and Swagger. So this is a full both development time environment, but also a runtime environment. that makes it possible to write very, very advanced applications rather quickly. And here we see what we are doing, the Hyperledger Composer, the BNA file, and the Hyperledger Fabric. So then we have deployed our application in the Hyperledger Fabric, and we are ready to run. Now we come to an important point here, and I want to spend some time in going through this. For high-performance enterprise business networks, it may be best to write chain code natively. And I have information about that here in the read the docs. The reason is that the BNA file has a certain amount of overhead during the runtime. This is not something that makes a difference when you write applications that you are simply testing out, or if you write smaller applications. But if you are going to write a major enterprise level application, it may be best to write chain code natively. And this is not very much more difficult than what we have already shown, but it is a little bit different from what we show. And here we can show an example of chain code, also known as smart contracts. We have the application. We have a car application here. You can create a car. You can query all cars. We can query car properties, update car color, update car owner, and any other functions we want to add. And on the right there, you see the ledger, and then we can update the make, model, color, and owner any way we want to with the smart contracts or chain code. The chain code has two personas. One from the perspective of an application developer. That's us here now who are writing applications, but also for the operator is a second persona, which allows you to add chain code, delete chain code, and update it. So there are two types of people working with chain code. Again, the developers and the operators. Now, as I said, we will also then add a GUI to this thing, a user interface, which we'll show you how to do next week. And this really is all there is for writing applications on the blockchain. And we have some information here about the chain code. One important thing here is that it handles business logic agreed to by the members. So it may be considered as a smart contract. State created by the chain code is scooped exclusively to that chain code and can't be accessed directly by another chain code. This is important to realize. But within the same network, given the appropriate permission, a chain code may invoke another chain code to access its state. So chain code, therefore, is the way we program the ledger, and something that the ledger executes, and then is what makes it run. And that pretty much is what I had for this presentation. It's important to realize that you can get started by creating these chain code very quickly with the Composer. And I would urge you to spend some time this coming week writing Composer applications and taking the applications that we already have and modify them. When I was down in Silicon Valley Labs, that's what we did. We took some of the existing applications, we modified them, and within a few hours, we had brand new applications running that we were able to test, and that we were able to add a GUI, a user interface to, and we came in third in this very competitive event. So I think that is what I have here, and we can see if there are any questions.
Great. I do think we have a few questions, so let's go down to the Ask a Question section. Okay. So the first question is, if I understand correctly, chain code does not live on the blockchain like a smart contract would. It's a single hosted instance.
It runs on the ledger, as I pointed out, yes.
Awesome. Next question, also by Corey, assuming that you can CRUD participants. I think this was while you were speaking, he was asking a question.
Okay.
Got it. create, update, and delete, assuming that you can.
Right, yeah, correct, yes. Yes, create, update, and delete, yes.
Awesome. Thank you for the clarification, Corey. Do these transactions that update values cost some gas? If so, how is that calculated and paid?
There is no gas here. We are running without gas, as it were. This is Hyperledger. This is not Bitcoin. That's an important point to make also, that as we pointed out last week, Hyperledger is not the same as Bitcoin or Ethereum for that matter. They're two different words. And it's kind of unfortunate in a sense that we are using the word smart contract here. It is similar to smart contracts, the chain code, but it's not identical to it. And maybe we can say it's somewhat simpler because it's focused on the business world and not on the Ethereum world. But that is something we can go into deeper later on in the next session.
Great. And then our next question from Faraz is, what does natively mean when said for big enterprise apps? Maybe best to write chain code natively.
Yeah, the important thing here is that there is a slight overhead in running the Composer code. So for most people, this should not be an issue using the Composer. But again, you can do timing estimates and see how many seconds you want a certain functionality to run in, and that is something that you only have to worry about, I would say, if you're going to write a very, very large enterprise application where performance, you need so many transactions per second, for instance. And that is something that you can easily measure. And having measured it to see if you can meet that environment, that goal rather, then you will see if you have to move away from the Composer maybe and use write native code, so to speak.
Okay. The next question is, can chain code be updated once deployed, or will update and create a new address for the new chain code?
You can update it, of course, yes. You can update it and run the new version of it, yes.
Okay, next question. Hyperledger Fabric hosted by Linux Academy, is it just the blockchain running for test purposes as it is centralized?
Can you repeat that? Because I didn't quite understand that.
Sure. And if there's any questions you're unsure about, we can go after the session and then answer them.
Right.
With a little clarification. Okay, Hyperledger Fabric hosted by the Linux Foundation. Is it just the blockchain running for test purposes as it is?
No, this is, it's not hosted by, by Linux Foundation. Hosted, yeah, I mean, it's managed by the Linux Foundation, but it's not a runtime that you can run against. The Hyperledger Foundation, rather the Linux Foundation hosting of the Hyperledger Fabric contains all the code you need to instantiate it and run it. You can run it on your laptop, but you can also run it in the IBM cloud or in other clouds. So this is the full code, and it is very well performed, very high performance. So it is everything you need to run, to write applications, and to write very advanced applications for that matter.
And then he clarified, he said, so where is it running on people's computers?
Oh, where is it running? Well, if you take down the Hyperledger Fabric code from GitHub, you take it down to your laptop, you run it on your laptop, and that is fine. It's all free. You can run it as much as you want to without paying a cent. You can run very advanced applications. But if you want to run it in a typical hosted environment, then you can run it in the IBM cloud or also in AWS and other clouds. Then you pay money for the hosting, but not for the code itself.
Awesome. And then we're going to take 2 more questions, and then Lennart's going to go back and answer them after the session. So the next one is, can Hyperledger work offline if network is down, for example, or you're on a plane?
That is a very interesting question. It is a distributed environment, so typically all the peers have to communicate with each other. So if the entire system is down, which would be not very likely, but if the entire system is down, it would be like part of the internet was down. And if the part of the internet is down, yours have to sit there and wait. You cannot continue to work in that case. But keep in mind that it's a distributed environment, and you can therefore do failover. And let me talk about that for a second. The peers are all the same. They all contain the same runtime code. If therefore we have a malevolent party who is trying to knock out our Hyperledger network, they would have to knock out all the nodes. As long as one, or even as long as even one node is still working and running, the network will be up and running. So I don't see that as being very likely. Really.
Great. And then we're going to take the last question. How about from Alejandro? How secure is Hyperledger, e.g. against someone hacking it and modifying changes?
Yes, another very good question. If you can hack it, you will have to be really good. You will have to have enormous resources. Because keep in mind that the blockchain itself, which is part of the Hyperledger, is a system that is built for security. All of the nodes are linked together. There is no way for you to break into this system without everybody immediately understanding what's happening. You cannot break in there anonymously and get anywhere. Therefore, it is the safest system. It's the most secure system that you can imagine. And yes, you can break any system. You can break into Fort Knox here in the United States if you want to. But you would need so many resources, so much money, that it wouldn't be worth your while to try to break into a Hyperledger fabric network. You would need more money than it would cost you to create the network itself.
Awesome. And I'm going to answer a question by Rakesh. So you mentioned how can you get last week's and this week's slides? We'll be sending out an email this week with the slides attached, as well as some other resources, and Lennart's Twitter, so you can contact him. And last week's slides, we've already sent out an email last week, but if you haven't received that, please do let me know, and I will be sure to get that to you. Cool. So as long as you've registered for this session on Crowdcast, you will be receiving the slides and a recording. And this recording will actually be accessible to you right after the session. Awesome. So thank you so much, Lennart. And thank you everyone for joining us today, and we hope to see you next week as well.
Yeah, thanks everyone.
Awesome. Bye.